Hello learners and welcome to a Natural Sciences lesson. So today we're going to be dealing with the formation and the prevention of rust. But before we start, did you know that the reason why metals turn red and they crumble it is because of rust? So in this lesson you're going to be finding out how we can prevent rust and how rust is formed when we are dealing with the metals. So then, in doing that, I would expect the following from you, that by the end of the lesson, this is what you should be able to do and this is what you should be able to know. Now, number one, you need to be able to explain the formation of rust. You also need to know how to make iron rust resistant. And then lastly, I want you to be able to explain why rusting tends to happen much faster near the ocean. Then, in dealing with the formation and the prevention of rust, we're going to be looking at two separate ideas. Number one, how rust is formed, and then number two, how can we prevent that rust from forming. Then throughout this entire lesson, we are going to be using certain words, and then you might be hearing that some of them they are familiar, some of them are not. But with what we know, I want us to look at this. We know that almost all metals reacting with oxygen form a metal oxide. Now, this metal oxide is formed by a reaction between a metal and oxygen. So when metal reacts with oxygen, it forms a metal oxide. Then now, which metals are we referring to and which metals are we talking about? So in the periodic table, you'll find that we have metals, nonmetals, and metalloids. So we have a lot of metals in the periodic table, but you're going to be mainly dealing with the two that are found in group 1 and in group 2. So when metals from group 1, and those ones are called alkali metals, when those metals in group 1 react with oxygen, they will have the formula of M2O. That means the ratio between the metal and the oxygen is going to be 2:1. That means for every 2 metal atoms that you find from group 1 atom, they are going to be reacting with 1 oxygen atom from the periodic table as well. Then now, when we are talking about the elements in group 2, remember that those ones, they are given the name alkali earth metals. So the difference is that these ones are alkali metals, whereas the group 2 metals are called alkali earth metals. So when those ones react with the oxygen, again from the periodic table, the ratio is going to be 1:1. That means for every 1 metal, we're going to have 1 oxygen. So in simple terms, the formula or the compound of the metal oxide formed is just going to be MO. Whereas from the elements in group 1 will be M2O. Now, with what we know, we need to be able to answer these questions, these two simple questions. Firstly, we are given that we need to consider the chemical equation for this reaction, whereby we are given Fe plus O2 reacting to form Fe2O3. Remember that Fe is iron, and then O2 is oxygen. It is written as O2 because it's a diatomic molecule, and we find oxygen in the periodic table in group 6 or group 16. And then now the product formed between when these two substances react, when this metal and this oxygen react, it is going to be Fe2O3. And this is your metal oxide or your iron oxide. So in general, this is going to be the metal oxide. Then its specific name, it is going to be your iron oxide. Now, what is asked about that particular reaction? The question that is asked firstly is that we need to balance the above reaction or the above equation. So remember that when balancing the equation, we need to make sure that the number of atoms on the left-hand side are equal to the number of atoms on the right-hand side. On the left-hand side, remember we find the reactants. If there's more than one reactant, they are separated by the plus sign. And then on the right-hand side, we find products. Again, if there's more than one product, they will always be separated by a plus sign. Then to separate the reactants and the products, we have the arrow, which is a yield or react to form sign. So it says that the reactants are going to react together to form or to produce the products, which are going to be on the right-hand side. Now, let's balance the equation. We need to start by calculating how many atoms we have on the left-hand side and how many atoms we have on the right-hand side. So by inspection, we are seeing that the reactants and the products, that on the reactants, we have 1 iron, and then on the products, we have 2 Fe. Or we can just say Fe is equals to 2. Why? Because of that subscript 2. It goes for only just that particular atom. Now, with regards to the oxygen, it is O2. So the oxygen, we have 2 of them. And then on the right-hand side, we have 3 of them. So the products, we have 3 oxygen. So with that said, we can clearly see that both the atoms, or both the substances on the reactant side and the products, they are not balanced. So we need to balance them by adding more molecules either on the left-hand side or on the right-hand side, depending on where we need to balance. So firstly, we are seeing that we have 2 ions on the right-hand side and we have 1 on the left-hand side. So to balance that, we are starting with that number 2, so that if we add a 2 here, we now know that that Fe is going to be taken care of, because we have now 2 ions and then 2 ions on the right-hand side. But then still, the oxygen is not balanced. Remember that when we are balancing, I cannot just subtract a 1 here, or I cannot just change that 3 into a 2. Whenever I'm balancing equations, I'm always changing the coefficients, not the subscripts. The coefficients are written on the on the left-hand side of the chemical formula. Just like this 2 here, it is a coefficient, whereas this one here, it is a subscript. So in balancing this equation, I can also change the subscript on the product and put in, let's say I put in a 3. If I put in a 3 now, that 3 is going to affect this 2. That 3 will also affect that 3. So now 3 multiplied by 2 is going to be giving me 6, and then 6 is no longer equals to 2. And then 3 multiplied by 3 will give me 9, and that 9 will not be equal to the 2. So now, let's see what number can I use to balance that. The smallest possible number that I can use, let's start with the 2 again, as I've said, starting with the 2. Remember, the 2 will affect the 2. The 2 will also affect the 3. How? 2 times 2, it's 4. So on the products, I will have 4 ions. But then still, I have 2 there. Now, let's look at the oxygen. 2 times 3, I have 6 oxygens on the right-hand side. And then 6 oxygen on the right-hand side. And then on the left-hand side, I still have 2. But then that I can quickly fix by just substituting or changing that 1 into a 3. Now I know that 3 multiplied by 2 is 6, so oxygen is balanced. But then I'm still faced with the problem that I have 2 ions on the left-hand side, and then on the right-hand side I have 4. So if I just change that into a 4, that takes care of everything that I am struggling with. So if I do this, put this 4 there, now I have 4 ions, 2 times 2, 4. 3 times 2, 6, and then 2 times 3, 6. So therefore, the iron is balanced and the oxygen is balanced on both sides. Now, the next question is asking us to give the word equation for this reaction. So therefore, the word equation for this particular reaction is going to be iron reacting with oxygen, reacting to form iron oxide. Also, remember that the equation, the word equation, doesn't tell us how many atoms of each of these substances are. So by looking at the word equation, we can't tell whether the reaction is balanced or not, right? So to balance this equation, remember it's already balanced, we're just rewriting it, Fe plus 3O2 reacting to form 2, Fe2O3, right? So throughout this entire lesson, I'll be using words such as corrosion, rusting, electroplating, galvanizing, and lastly, chemical equation to better explain how rust is formed and how we can also prevent the rust that you're going to be talking about. So before we get started with the formation of rust, we're going to quickly take an ad break, and I'll see you just after this.